Students, now we are going to know about the thing by which the matter has been created. Can any one of you tell me the name of that particular thing? Yes, you, Rahul.
Sir, it is atom.
Absolutely right. Atom is the smallest thing by which matter is made. Now let us study further to know more about atom. Objectives. At the end of this lesson, you'll be able to describe the different models of an atom, recall Thomson's atomic model, discuss Rutherford's model of an atom and its defects, explain about Bohr's model of an atom, recall distribution of electrons in different orbits, distinguish between atomic number, mass number, isotopes, and isobars. Atom. The word atom is derived from the Greek word atom, which means indivisible. The Greeks concluded that matter could be broken down into particles too small to be seen. These particles were called atoms. Atoms are composed of three types of particles: protons, neutrons, and electrons. Protons and neutrons are responsible for most of the atomic mass. Both the protons and neutrons reside in the nucleus. Protons have a positive charge, neutrons have no charge and they are neutral. Electrons reside in orbitals around the nucleus. They have a negative charge. It is the number of protons that determines the atomic number. That is, H is equal to 1. Isotopes. The same element may contain varying numbers of neutrons. These forms of an element are called isotopes. The chemical properties of isotopes are the same, although the physical properties of some isotopes may be different. Some isotopes are radioactive, meaning they radiate energy as they decay to a more stable form, perhaps another element half-life. Time required for half of the atoms of an element to decay into stable form. Another example is hydrogen, with atomic number of 1 can have 1, 2, or 3 neutrons. Thomson's model of an atom. J.J. Thomson proposed that an atom was a solid sphere of positively charged material, and the negatively charged particles, electrons, were embedded in it like the seeds in a watermelon. The red edible part of the watermelon is compared with a positive charge in the atom. Thomson stated that an atom consists of a sphere with positive charge. Electrons are embedded in that sphere. The atom as a whole is electrically neutral since the negative and positive charges are equal in magnitude. Although Thomson's model explained that atoms are electrically neutral, this was proved wrong by the other scientists. Rutherford scattering experiment. Ernst Rutherford carried out experiment in which charged particles were shot through thin foils of metals like platinum and gold. The charged particles used were the alpha particles having mass 4 times that of a hydrogen atom and positive charge twice the magnitude of the charge of an electron. A thin foil of metal was expected to contain a few layers of atoms. The motion of charged particles incident on the foil was expected to get influenced in different ways depending upon distribution of positive and negative charges and mass within the atoms. On the basis of Thomson's model of atom, it was speculated that on passing through the metal foil, the charged particles would get deflected through a small angle. 1. Most of the space inside the atom is hollow or empty, which allows the particles to pass straight through without being deflected. 2. There is some positive center present in the atom, which deflects or repels the particles, like charges repel each other. This positively charged heavy body in the center is known as the nucleus. 3. The total volume occupied by a nucleus is very small as compared to the total volume of the atom, as very few particles are repelled or deflected by a wider angle. Rutherford's atomic model. Based on his experiment, Rutherford put forward the nuclear model of an atom. According to this model, an atom consists of a positively charged center, the nucleus. At a considerable distance from the nucleus, the electrons were orbiting in a manner much like the way the planets orbit the Sun. Hence, this model is also called as planetary model of atom. The number of electrons in orbits is equal to the number of positive charges, protons, in the nucleus. Hence, the atom is electrically neutral. The volume of the nucleus is negligibly small as compared to the volume of the atom. For example, if we consider the radius of the atom is equal to 1 kilometer, then the size of the nucleus will be equal to a cricket ball present in the core center of the atom. Hence, most of the space in the atom is empty. Drawback of Rutherford's nuclear model of an atom. Rutherford's model has the drawback that as the nucleus and electrons are held together by electrostatic forces of attraction, it would lead to the fusion of the nucleus with electrons. This does not happen in the atom. For this, Rutherford gave the explanation that electrons revolve around the nucleus in a spiral path. This too is not satisfactory because in following a spiral path, energy is lost by the electrons and ultimately they will fall into the nucleus, but atoms are stable. Bohr's model of an atom. Niels Bohr, 1913, proposed a modified model of atomic structure in order to overcome the difficulties of Rutherford's model, which is the first step towards modern atomic theory. The postulates of this theory are: 1. Electrons revolve around the nucleus in a limited number of orbits called permissible orbits. 2. Each of these fixed orbits has a definite energy, hence they are also known as energy levels, energy shells, or stationary states. The energy of the K shell is the least, while those of L, M, N, and O shells increases progressively. 3. The energy of an electron remains constant so long as it stays in a given orbit. Electrons present in different orbits have different energies. 4. When an electron jumps from a lower energy level to a higher one, some energy is absorbed. When an electron jumps from a higher energy level to a lower energy level, some energy is emitted. The amount of energy absorbed or emitted is given by the difference of energies associated with the two levels. Energy absorbed or emitted, delta E is equal to E2 minus E1, which equals h nu, where h is Planck's constant and nu is the frequency of radiation absorbed or emitted. Electron distribution in various shells. Bohr and Bury suggested the distribution of electrons into different orbits of an atom. The number of electrons present in a shell is given by the formula 2n square, where n is the number of orbit. The maximum number of electrons that can be accommodated in the outermost orbit is 8, and the penultimate shell cannot have more than 18 electrons. Valency. Valency is the combining capacity of an element, that is, the capacity of an atom to chemically unite with a definite number of atoms of other elements. The combining capacity of the atoms of the elements that is explained in an attempt to attain a fully filled or octet configuration of outermost shell. Boron has a valency of 3 and carbon has a valency of 4, since the outermost shell has 3 and 4 electrons respectively. Since fluorine has 7 electrons in the outermost orbit, it loses 1 electron to attain the octet configuration. So, the valency of fluorine is 1. Atomic number. The atomic number of an element is the number of protons present in the nucleus of an atom. Since an atom is electrically neutral, the number of protons and electrons is equal. Therefore, atomic number is also the number of electrons present in an atom. Mass number. The mass number of an element is the sum of the number of protons and neutrons. Let Z be the atomic number and A be the mass number of element. Then the number of protons in the atom is equal to Z. The number of electrons in the atom is equal to Z. The number of neutrons in the atom is equal to A minus Z. Structure of the hydrogen and oxygen atom. Hydrogen atom. Number of protons, P is equal to Z, is equal to 1. Number of electrons, E is equal to Z, is equal to 1. Number of neutrons, N, is equal to A minus Z, which is equal to 1 minus 1, which equals 0. Therefore, the nucleus of hydrogen consists of only a proton. There is 1 electron in the first orbit. Oxygen atom. Atomic number Z is equal to 8. Mass number A is equal to 16. Number of protons P is equal to 8. Number of electrons E is equal to 8. Number of neutrons N is equal to A minus Z, which equals 16 minus 8, which is equal to 8. Isotopes. Dalton in his atomic theory stated that atoms of the same element are identical in all respects of size, shape, and structure. Scientists believed in this hypothesis of Dalton, but later it was disproved. An element may have more than one kind of atoms. They may have same number of electrons and protons, that is, same atomic number, but they may differ from each other with respect to number of neutrons, that is, they may have different mass number or atomic mass. Such atoms of an element are known as isotopes. Atoms of the same element, rather elements having same atomic number, Z, but different mass number, A, rather atomic mass. In other words, isotopes differ from each other with respect to number of neutrons. Almost all elements have isotopes. Isotopes of hydrogen. There are 3 isotopes of hydrogen. 1. Protium. 2. Deuterium. 3. Tritium. Isobars. Atoms of different elements with different atomic number but with the same mass number are called isobars. For example, calcium and argon have different number of electrons and have different atomic numbers. But they have same mass number as 40, and so they are said to be isobars. Did you know, in 1911, Ernest Rutherford discovered that the majority of the mass of the atom is located in the nucleus. Most of the mass of the atom is located in the nucleus, which also contains the protons and neutrons. Protons are 1836 times as massive as electrons. Their positive charges are exactly equal in magnitude. Electrons cannot make a smaller orbit around the nucleus because, as quantified by Heisenberg's uncertainty principle, the wave-like nature of the electron prevents it from being confined to a smaller area. Summary. Let us summarize what we have learned. J.J. Thomson proposed that an atom was a solid sphere of positively charged material and the negatively charged particles' electrons were embedded in it like the seeds in a watermelon. Rutherford's alpha scattering experiment led to the discovery of the atomic nucleus. Rutherford proposed that electrons were orbiting in a manner in the same way as the planets are orbiting the Sun. Hence, this model is also called as planetary model of atom. Bohr proposed that electrons are distributed in different shells with various energy levels. The atomic number of an element is the number of protons present in the nucleus of an atom. Atoms of the same element, rather elements having same atomic number Z but different mass number A, rather atomic mass, are called isotopes. Atoms of different elements with different atomic number but with the same mass number are called isobars.